decomposition reactions. One example is metal hydrogen carbonate. If you heat a metal hydrogen carbonate, it'll form a metal carbonate, water, and carbon dioxide. The formula for the metal carbonate, oh gosh. I'm going to fix those things. For the metal carbonate is predictable because the charge on the ion doesn't change during this sort of reaction. So here's an example. Sodium hydrogen carbonate is baking soda. If you heat baking soda, it decomposes into sodium carbonate, water vapor, and carbon dioxide gas. And we can predict the formula for this metal carbonate because the sodium still has its +1 charge. It's not going to change. Let's look at some examples. Barium hydrogen carbonate is decomposed with heat. They're not telling you the products here. You're supposed to remember the products. The products are a metal carbonate, water, and CO2. So the water and CO2 are always the same. The products will be the same for these metal hydrogen carbonates. So barium hydrogen carbonate. What's the charge on barium ion? 2 plus, because it's in group 2. And hydrogen carbonate is 1 polyatomic ion. It's HCO3 minus. You're supposed to memorize that. So when we put those together, we get Ba HCO3 2. And this one is not giving us any information. It's not saying gas and liquid and stuff. So I'm just going to ignore state symbols. Heated, and it decomposes. So what's going to happen is I'm going to get the barium ion is still going to be there, but now instead of being hydrogen carbonate, it's going to be carbonate. So I look at those two ions and I get BaCO3, and then I just remember the other products, water and CO2. Can you use baking soda to put out like a kitchen fire? Yeah, you can. It works really well. You know why? Because when you throw it on the fire, it decomposes and gives off carbon dioxide, which displaces the air and the oxygen and helps to prevent the fire from burning. So baking soda makes a great fire extinguisher. Is this balanced? People are saying no. I disagree. Tricky. Notice this is a situation where the CO3 is not staying together. So I have CO3 here and a CO3 here, but I also have a carbon that's only with 2 oxygens. So I have 1 barium and 1 barium. In this molecule formula unit, how many carbon atoms are there? 2, right? And over here I have 1 carbon, and there's the other one. How many hydrogens are over here? HCO3, 2. So the 2 multiplies the hydrogen. There's 2 hydrogens in there. And over here, how many hydrogens? 2. How many oxygens? 6. 3 plus 1 plus 2 is 6. Tricky. Copper 1 hydrogen carbonate. Cu plus HCO3 minus. So when we put those together, we don't get calcium. Cu HCO3. decomposed with heat. Two of the products we can just flat out write down, H2O and CO2. And the other one is going to be the copper ion, same charge, but with carbonate instead of hydrogen carbonate. So CO3, 2 minus. So that's going to be Cu2CO3 because of the charges. I need two of the coppers to balance the charge on the carbonate. Is this one balanced? No, we wish it was, but it's not. Here's one copper, two copper ions. So we'll put a 2 in front of our reactant. 2 coppers, 2 coppers. How many hydrogens on the left? 2. How many hydrogens on the right? Great. How many carbons? How many over here? 2. There's one here, and there's one over there. How many oxygens on the left? And how many oxygens on the right? 6. 3 plus 1 plus 2 is 6. So that wasn't too hard to balance. Any questions? Another type of decomposition, metal carbonate. Where might you get a metal carbonate? From heating a metal hydrogen carbonate. If you heat it further, you can decompose it into a metal oxide and more carbon dioxide gas. And again, the charge on the metal ion doesn't change. So calcium carbonate, if you heat it, you'll get calcium oxide and the CO2 leaves. Oh yeah, there's more examples. Okay, aluminum carbonate. What's the charge on aluminum ion? 3 plus. Group 3 on the periodic table. Carbonate is CO3, 2 minus. You memorize that. That's a really big minus sign. 3 plus, 2 minus, great place for crisscross applesauce. Al2, CO3, 3. So that's aluminum carbonate. And you know, if you were doing a problem like this on homework, figure it out like that, and then say, oh Google, what's the formula for aluminum carbonate? And it'll probably pull up a Wikipedia page and it'll show it to you. And then you say, oh, great, I'll go on, or, ooh, I don't know about that, and fix it. Decomposed on heating. What does it make? We're going to need CO2 and metal oxide. So it'll be aluminum oxide. The charge on the metal doesn't change, so it's still Al3 plus, and oxide is O2 minus. So we're going to get Al2O3 plus CO2. Then we need to balance this. 2 aluminums, 2 aluminums. How many carbons over here? 3. There's 1 inside the parentheses, but we have 3 of those groups. And over on the right, we only have 1 carbon. So we need to put a 3 there, so the carbons are balanced. How many oxygens in this guy? 9. 3 times 3 is 9. How many oxygens in this one? 3 and 6 is 9. Iron 2 carbonate is decomposed on heating. Iron 2 is Fe2 plus. Carbonate is CO3, 2 minus. So that's FeCO3. Arrow with the triangle, meaning that we're heating it. Products are metal oxide plus carbon dioxide. The metal oxide, the iron is still 2 plus, oxide is O2 minus. So FeO plus carbon dioxide. Is that one balanced? Yeah, it is. Any questions? Then we can have another type of decomposition, miscellaneous oxygen-containing compounds. If you have oxygen-containing ionic compounds and you heat them, they will often decompose and release oxygen gas. These are unpredictable, though. So like those last ones, we made you predict what the products were. This sort of a reaction, we have to tell you with at least the name what the product is. Solid lead 4 oxide decomposes upon heating to give solid lead 2 oxide and oxygen gas. There's no way you could predict what the products are. But given that sentence, we can write the balanced chemical equation. So lead 4 oxide. That means Pb 4, that's not a 4, 4 plus, oxide O 2 minus. If you're still rusty on the nomenclature, we need to get that straightened out before the exam in 2 weeks. So I put those together. This is a 4 and a 2. This is where we have to be careful. We ran into this person earlier. We just need 2 of these oxygens to balance the charge on the lead. This is PbO2. It's not specifically saying you have to write the state symbols, but since they're telling me a lot of these things, I'm going to include it just for grins. Most ionic compounds are solids at room temperature. So this decomposes upon heating, forming lead 2 oxide, Pb2 plus oxide. So when I put that together, that's just PbO. That's also a solid. And oxygen gas, O2 gas. Any questions? Is it balanced? No. There's 2 oxygens here, and there's 1, 2, 3 oxygens over there. What do we do? Well, if we had 2 of these, would that make things easier? Then we'd have 2 plus 2, we'd have 4 oxygens. And then over here, we could multiply this by 2. And are the leads okay now? 2 leads and 2 leads. Yeah, those leads are okay. One way to practice doing this is to go to the YouTube channel and get through to like a point right here where I'm going to do this one and try to do it yourself. And then if you get stuck, play it forward a little bit until you think you know that you can keep going. And so you can kind of practice like that. And then if you still have trouble after doing that, please send me a text message and we'll figure something out. We'll figure out a way to help you. Aqueous hydrogen peroxide. And we have not learned how to write the formula for hydrogen peroxide, so I'm giving it to you. It's H2O2. How do I indicate that it's aqueous? AQ. Decomposes on heating to give water and oxygen gas. Well, water's H2O. What do you think the state of that is? Probably a liquid. And oxygen gas. This actually occurs if you've got hydrogen peroxide solution for cleaning out wounds or something, and it's just sitting around. If it's in a hot environment, like you left it in your trunk, it's going to decompose a lot faster. Is it balanced? No. What do we do? Yeah, if we put a 2 here, now we've got 4 hydrogens and 2 plus 2, 4 oxygens. So then if we come over here and put a 2, we can get it straightened out. Questions?